Cool. All right, g'day guys. If you are watching this, that means that you have done the home study or you are studying it. So thank you. I appreciate those of you who are putting in the effort in class and outside of class. It's really good to see. For the first question here, as a reminder, we're replacing x, right, in that equation with each of these numbers in the table, right? And then whatever we get when we put in those x values, whatever our output is going to go here. In the y value. So for example, the first one with the 0, I'm going to write y equals 2x plus 5, right? But instead of x, we're going to put 0. And when the 2 is next to the x like that, it actually means 2 times x, hence why I've done 2 times 0 there. In this case, 2 times 0 is 0, plus 5. 0 plus 5 is 5, so in this box here, I'm going to put a 5. Then we're going to do the same thing, except instead of 0, it's going to be 1. And 2 times 1 is 2. 2 plus 5 is 7. So I'm going to put a 7 here. Then, instead of putting a 1 in, we can see next up we've got to put a 2 in. Whoop. Just did that in the wrong spot, my bad. Next up, we've got to put a 2 in, so I'm going to replace it with a 2. 2 times 2 is 4. 4 plus 5 is 9, so I'm going to put the 9 there. Same thing, now we're replacing with a 3. And this time, we're going to get 11. Last one, we're replacing with a 4. We'll get 8, and then 13. Awesome. All right. Same story with this next one. Okay, we're using y equals 4 times whatever x is, right? Times whatever x is, minus 2, and we're going to make our substitutions. So in this first case, x equals 0. So 4 times 0 is 0. Still got that minus 2. 0 minus 2 is negative 2. So I'm going to put a negative 2 there. For the next one, we're going to be replacing it with a 1. 4 times 1 is 4. 4 minus 2 is 2. So I'm going to put a 2 there. And look, hopefully you've kept up at this point. I'm going to start doing them in my head. Okay, so we get 4 times 2 is 8. 8 minus 2 is 6. 4 times 3 is 12. 12 minus 2 is 10. 4 times 4 is 16. 16 minus 2 is 14. All right, moving on. This one here, we're asked to graph the following table of values. So for each of these, I want to plot these points. So this is a pair of points, this is a pair of points, this is a pair of points, and so on. I'm going to put each of those pairs of points onto my Cartesian plane, and then I'm going to be able to connect them up to graph my line. So the x coordinate, as we can see, is the top one. The y coordinate is the bottom one. On my Cartesian plane, I can see x is there, y is there. So when it says x is 0, I'm looking here, right, when you can see that little speck of blue I just dabbed on, hopefully. And then I'm going to where y is equal to 3. So I'm going up 1, 2, 3. Okay, bang. There's my first point. All right. This first little blue I've just rubbed out there was just to show you where I was looking. Okay. Then I'm looking at where x equals 1. Okay, so I'm starting here, and then I'm going up 7 to track y. So I'm going up 7. That is my point there. Okay. For my next point, I've got x equals 2, so I go across 2 to the right, and then we're going up 11. So I've actually managed to give us a question with a slightly unsuitable Cartesian plane, so I do apologize for that. So it's actually going to hinder me doing the rest of this slightly, but that's all right. So next up, we would go to 3 and then all the way up to 15, which, you know, is going to be somewhere up here. Look, for argument's sake, we're just going to graph what we can. We have actually got enough information here. So using a ruler on the iPad, a little bit dodgy. Okay, but we'll do what we can. Nope, doesn't want to play ball. Okay, that kind of worked. All right. And then as long as we know that this line goes on forever in that direction, and forever in that direction, I would be happy with that answer. Okay. Question 3. what is the gradient of the following lines? Well, if you guys remember, the first step I want you to do with these questions, I want you to pick two really nice points on this line. So I can see it hits straight on the corner of the grid, right? Like in the crosshair of the grid, so to speak. Crosses through one of the crosshairs of the grid quite nicely there. It does the same thing up here, okay? Then I'm going to look how far that way have I gone and how far that way have I gone to get to that point. Well, I've gone from 2 to 6 across, so I've traveled 4 units to the right. And then I've gone from 1 all the way up to 4, going up. So I've traveled 3 units up. If I use the formula I've given you guys in class, m equals rise over run. My rise here, I've gone up 3, so my rise is 3, and my run is 4, I've gone across 4. All right, and that's the gradient. Remembering that m is the letter we use to represent the gradient. All right, same thing here. I've got not great points on this one. There is a point there you could use, there is a point there you could use, and there's a point there you could use. Fun fact, whichever ones you end up using, you'll get the same answer. I'm going to use these two here, so I'm going to go there and there. In this case, you'll note I'm going down, okay? And so that's going to be important later, all right? So don't forget that. We're going down. I've gone down 2 there, and then I've gone across to the right 5. Same formula as before, rise over run, except it's not really a rise this time. It's more of a fall. So because we're going down, I'm going to put a negative in front of that 2, all right? And keep that over the 5. And look, in this case, we can leave that as a fraction. I'm absolutely happy with that being our final answer. All right. Next one here, same story. Nice point there. And I feel like that's the next nice point there. Okay. Which means we have a big fall there, big run there. I'm falling all the way up from 8 down to 0. So I've gone 8 down. And I'm going from 1 across to 7. I've gone 6 across. Same formula as before. Rise over run. Because I'm going down, I'm going to put -8. Okay. This time I can simplify that though. This time I can say, I can divide the top and bottom by 2. And I can get -4 out of 3. Okay. And that would be my answer. Awesome. All right. We are on a good roll here. What is the gradient of the line that connects the following points? All right, if you guys remember with these ones, I want you to label the points. So x1, y1, x2, y2. Because remember, when we write a point like that, right, with a number here and a number here, this is the x value, this is the y value. So my first x value, first y value, second x value, second y value. And if you remember the formula for this one, we do y2 minus y1 over x2 minus x1. And then I'm going to replace each of these symbols, so y2 and y1, with the numbers above them. So the number above y2 is 17. The number above y1 is 7. The number above x2 is 3. And the number above x1 is 1. 17 minus 7, well, that's 10. 3 minus 1, well, that's 2. 10 divided by 2 is 5. So we have, for this first case, my gradient is equal to 5. Same process with this second one, x1, y1, x2, y2. Same formula. Only thing that's a little bit harder this time is we've got some negatives. So y2 is actually going to be -11. And we still have that minus in our formula, minus y1, which is 5, over x2, so -1 minus 5. -11 minus 5, well, that's -16. -1 minus 5, well, that's -6. When I have a negative over a negative, they can like cancel out so that they disappear. Okay, so I'm actually just going to get rid of them. So the negatives are gone. Now I'm looking at this and I'm like, can I simplify that? Yes, I can. Let's divide the top and bottom by 2. We'll get 8 over 3, and that is my gradient. Awesome. All right. Find the equation of the following straight lines. Okay. If you remember for these ones, I want you to draw this. So y equals something x plus something. All right. And remember, this bit here is my gradient. And this bit here, my y-intercept. So in this case here, I can see straight away that my line cuts the y-axis right there. All right, that point there. That point there is, if you can't see, is the number 4. So I'm going to put a 4 in here. Okay, so it cuts the y-axis at 4, or it intercepts the y-axis at 4. We put 4 there, and then my gradient, well, we're doing the same thing as we did in previous questions. So I'm comparing 2 points, so I'm just going to do those two there. Rise and run. I've run 1, going from 0 to 1. I've gone up from 4 to 10, so I've gone up 6. If I do rise over run, that's going to be equal to 6 over 1, which is equal to 6. So gradient's going to be 6. Cool. All right, next question. I'll use a different color so we don't get confused. Something x plus something. Same story as before. This time I'm cutting the y-axis at 6, so that one's going to be 6. This time my gradient, I'm just going to use the point I used a second ago and that one there. They both look like nice points. So in this case, I go down from 6 to 0, so I go down 6. Remember, the down is important. And I'm going 3 to the right. Okay, so rise over run. In this case, well, it's a fall, so I'm going to do -6. And my run was 3. -6 over 3 is, 6 divided by 3 is 2. So we have -2. And that is going to be my gradient, -2. All right. Next one here, we have, let's use a different color. We have the same sort of request. First things first, we have the y-intercept there, which passes through at 2. So that's going to be +2. Then I need to pick a couple nice points. That looks like a nice point there. Going across and then up. I've gone up, it looks like 1, but I've gone up from 2 to 4. So I've actually gone up 2. Hang on, that's probably a bit hard to see. Let's draw that again. Gone up 2, and I've gone across from 0 to 2. So even though the axes are like, make it look like this line, you know, is going further to the right than it is going up, it's actually 2 and 2. Because we go off the numbers, right? So like we've gone from here, we started at 0, and then we've ended up here at 2. And vertically, we started at 2, and then we ended up at 4. So both cases, we're jumping 2 spaces. So our rise over run is just going to be 2 over 2, which is equal to 1. So we have 1x plus 2. Okay, and look, there's nothing wrong too with if you want to write these equations out afterwards. Nice and simplified, you know, it is a good thing. If you don't do this though, not the end of the world. I'm not gonna punish you for it. I'm perfectly happy for you to leave them in the boxes. Okay, 6x plus 4. Awesome. All right. Equation that models the following table of values. Guess what, guys? We are using the same thing because we're still building an equation. Same thing. This time, though, to find my gradient, I'm looking at what am I jumping up by each time to get to each number. Well, I can see each time I'm adding 4, right? And if each time I'm adding 4, then my gradient's going to be 4. So I'm going to have 4 there. To work out what goes in the second box, well, I need to look when x equals 0. So for this box, when x equals 0, what does y equal? And I can see in this section here, it tells me when x is 0, y is 3. So we're going to put a 3 here. Same thing for the next one. All right, but I'll do a little bit less explaining. We're jumping up by 2 each time, it looks like. So plus 2 each time, which means we'll have a gradient of 2. But they haven't given us a box where x equals 0. So let's reverse engineer this a little bit. If we pretend that we had another box here where x was 0, what would be in the y value? Well, if going to the right, I'm adding 2 each time. To go to the left, I'm going to minus 2, right? If I went to go from 7 to 5, 7 minus 5 would be 2. And then to go from 5 to the next one below that, 5 minus 2 would be 3. Okay? And you can kind of test it because if I say that the plus 2 rule was a thing from earlier, does that work? Well, 3 plus 2 is 5. 5 plus 2 is 7, so on and so on. So, okay, good. We found that when x is 0, y is equal to 3. We can use that information now to tell us that we have plus 3. And that's our equation. And once again, you can, you know, if you want to write that a little bit nicer, you can write it like that. It's the same thing. Awesome. All right, find the distance between the points A and B in the following. All right, so this is the one that's like secretly Pythagoras. So we need to find the run and the rise. Oh, messed up there a little bit. Let's do that again. The run and the rise, as with other questions. In this case, I'm going from -4 up to 3. I've traveled 7 to the right. And I'm going down from -4 up to 3. I've actually traveled, 7 up. If I'm going to find my distance is going to be equal to the square root of the rise squared plus the run squared. In this case, we rose 7, so 7 squared. And I should put those brackets in because some of these questions with some calculators, you will get issues if you don't. Okay. And putting that into my calculator, we get 9.9 if we round it to 1 decimal place. Okay. Next one, same thing. All right. I've gone from 3 down to -4. I've actually fallen 7. And I've gone from -2 up to 2. I've gone 4 to the right. So the distance, like I said, rise squared plus run squared. Now, if we want to keep consistent with what we were saying like a little bit earlier, where was it? When we were finding the gradients and we were, putting these like negative values in for going down, you can do the same thing here, right? It doesn't actually affect it as long as you use these brackets. So even though my rise is technically a fall of 7, I can put in -7 and I'll still get the same answer, okay? As if I just use 7 in this case. So putting in -7 works. And then the run is 4. And putting that one in the calculator, -7 squared plus 4 squared. I'm going to round to 1 decimal place. I'm going to get 8.1. Okay, but if you go like 8.06 or something like that, you're also right. Okay. All right, last one. Same thing. To get from point to point, so this point to that point, we ran 8. To get up to that point, we went up 1. So my distance, square root of the rise squared plus the run squared. This case, the rise was 1 squared plus the run of 8 squared. I'm going to calculate that one. I did forget to put the brackets on this time. That is okay with this question, but please, guys, do use the brackets. And you know what? I was rounding to 1 decimal with the other questions, so let's round to 1 decimal again. Okay. Cool. All right. Last questions. Same idea, okay, but to find my rise and my run, it's a little bit harder. So if we remember, my rise is the y coordinates. Y coordinates. So in that case, it's going to be 7 and 17. So to go from 7, so if this is my y coordinates, to go from 7 up to 17, well, I've gone up 10. Right, so my rise is 10. And my run, well, that's going to be my x coordinates. Okay, so that's going to be 1 and 3. So if I started at 1 and ended up at 3, well, I've jumped 2 into the right direction. So my run is 2 to the right. Okay, and so now we're actually doing the same thing as we did in the last question. All right, where we're saying that the distance d is equal to the square root of the rise squared plus the run squared. So that's going to be 10. I'll use the brackets this time. 10 squared plus 2 squared. Once again, not expecting you to do that in your head. Put it in the calculator, it's fine. We should get about 10.2. Awesome. Same thing as before. For my rise, I'm looking at the y coordinates, so 5 and -11. To go from -11 down here all the way up to 5, remembering that I've passed 0 at some point, I've actually traveled up 16. Okay, I've gone up 16 units, so my rise is going to be 16. For my run, with 5 and -1, I've started at -1, and I've ended up over here at 5. Once again, remembering I've passed 0 at one point there, so I've actually gone up by 6. Gone up by 6. So my run is equal to 6. And so bring it all together again. Rise squared plus the run squared is equal to, in this case we said the run was 16, and we said the run was 6. Put it in the calculator, 17.1. Cool. Awesome. If you guys made it this far, thank you very much. Once again, I appreciate you studying hard and putting in effort into maths. I hope you guys do really well on your test. And I will see you in class.